This is a video lesson on angles, and specifically angles in parallel lines. First up, some very basic angles and angle definitions. So two key terms that come up frequently are the following: complementary and supplementary. The word complementary refers to two angles that add up to 90 degrees. So how would you know that that's the case? Well, you'd be given a right angle. Or it could be in a context where you have a building compared to the ground, or a tree that you assume that grows perpendicularly to the ground. So you could be asked to find this missing angle because you know that the two of them add up to 90 degrees. You would do 90 minus the other to find your missing angle. And the word supplementary refers to two angles that add up to 180 degrees. And a straight line is a situation where the angles that form a straight line are supplementary. They add up to 180. So again, you could find the missing angle by doing 180 minus the angle that's given. That will tell you the angle that's missing. Cool. There's one other type of angle that is equal, or two angles that are equal to each other that don't have to do with parallel lines. It actually happens whenever any two lines cross at any angle. When two lines cross, they form four angles. There's one here, one here, one here, and one here. There are four angles in there. And there are two sets of equal angles whenever lines cross. The angles that face each other at the meeting point, those are called vertically opposite, and those angles are equal. So this is one set of vertically opposite angles, this one up here and this one down here. By virtue of being vertically opposite, they are equal. And similarly, these two here that I've drawn with very shaky, uneven lines, these two angles are equal to each other because they are vertically opposite to each other. Okay. There are also special cases that occur in parallel lines. So anytime you have two parallel lines, and this is true for 3 or 4 or 100 parallel lines as well, parallel lines are often indicated with an arrow on each one that go in the same direction that shows that these two lines are parallel. And you add another line that cuts through both of them. This line is called a transversal. So when you add this line in, there are 8 angles that are formed around the parallel lines and the transversal. There's one here, 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 and here. So in each case, above the parallel line, there's an angle to the left and to the right of the transversal. And here below this parallel line, there's one to the left and to the right of the transversal, and same for this parallel line. It's a total of 8 angles that are formed. And there are a bunch of special relationships. There are certain angles that are equal to each other, and they have certain special names. So, sorry, we went through this vertically opposite already. That's cool. It had nothing to do with parallel lines. That happens anytime lines cross. But the interior angles are the ones inside the two parallel lines. So if you think of these parallel lines as like train tracks, the ones in between the train tracks, those are called interior. So these angles here are the interior ones. They're the ones inside the parallel lines or inside the train tracks. And there are pairs of equal angles. The alternating ones, those are the ones on opposite sides of the transversal, those are equal. These two angles here are called alternate interior angles. They're interior because they're in between the lines, and they're alternate because they're on opposite sides. They form a Z as well. That's one way to check. Those are equal angles because they are alternate interior. And these are also, the ones that I've done in orange, another pair of alternate interior angles. They are equal. So just as a way to look, if you see a Z that's formed, could be backwards as well, those angles are alternate interior angles. And if these lines are parallel, alternate interior angles are equal. Okay. Alternate exterior angles, you might have an idea compared to the previous one. The exterior angles are the ones outside of the two parallel lines, the ones in this case above and below. Not in between the two lines, but outside of them. And again, the alternate exterior angles are equal. So meaning one on the left-hand side of the transversal, the other exterior one on the right-hand side. Those are alternate because they're on opposite sides of the transversal. They're both exterior. Those are called alternate exterior angles, and they are equal. And same for this pair here. They're alternate and they're exterior. Those angles are equal to each other. And you can tell that they kind of look like they're equal, but it turns out that they are in fact exactly equal if these lines are parallel. And finally, there's one other set. They are called corresponding angles. And corresponding angles are angles that are in the same relative position with respect to the parallel line and the transversal, the line that crosses through. What do I mean by that? Well, for instance, this angle is above its parallel line and it is to the left of the transversal. And this angle is above its parallel line and to the left of the transversal. They're in the same relative position. Those are called corresponding angles, and they are equal. And there are a bunch of other sets as well. This set, the ones where both of those angles are to the left of the transversal and below the parallel lines, those are corresponding. These ones over here, which are both above and to the right, are corresponding. And these ones here as well, which are to the right and below their parallel lines, those are called corresponding angles, and they are equal.